From the earlier videos, we showed you in step 1 we needed to inventory the configuration, software, and serial number of the endpoints. This is a basic BigFix functionality, and we're going to leverage this information on the re-imaged machines once they're running Windows 10. So we're going to show you a basic report that we created and the process to collect that inventory information. So we use basic BigFix analysis that comes out of the box that allowed us to drive our groupings or our automatic groups. For example, as we showed before, the different hardware vendors we were dealing with, very simple to get this information out of there. But also during our testing, we were able to do things such as the BIOS version, different models of the computer architecture to make sure that they could work with the UEFI booting that helped drive our groupings and help drive our adoption to Windows 10 and understanding which machines we could remove out of there. But I also mentioned that we did an inventory report. So I kind of want to show you what that looked like right now. And what that simply was, an incredibly simple report that we created called Windows 10 Migration Inventory. We did do some filtering on it. So again, we didn't want to get proxied machines, and only Windows machines are in here, not VMware. And an important UEFI, if the machine is already in UEFI mode, then we know we don't want it to target for this information. And we actually got that from bigfix.me. So we're using the community out there, which is great. But if you end up looking at this report, is incredibly simple. We got the identifying numbers, which is basically the serial number of the machine. Because once we re-image a box and wipe the machine's hard drive away, we need a way to tell it what its personality was before, its inventory and its host name. And this is how we do it. So when the new machine gets booted up, he pulls down this file, he looks for his serial number inside there, then he's going to know his name, and he's also going to know all the different types of software applications that were on it. So the software packages look inside this file on the box and are relevant if they find themselves, for example, listed in here. So a simple example in there is, hey, if he had Google Chrome before, he finds his entry in here, even the version number, then I will actually push that software out to the box. Incredibly simple to do this. We automated this a little further, is we created a scheduled activity. We run this approximately once a day or so forth, but the real change here was an incredibly simple batch file that we created, customized bat file, where we're actually copying this report to a location on the BigFix server so that we could actually push this data down to the newly imaged machines. And we're going to see where that looks like right here. Bear with me. So again, on my server, program files x86, we find BigFix Enterprise, the BigFix server. Of course, if we go down into www web roots, we created this OSD directory. We put files in here that we needed for this project. For example, the MDT bundle. We did modify this bundle to be able to work with our vendors and be able to make that switch into UEFI mode. But that automated report over here that I showed you creates this inventory file, and there it is, quite simple. And this is we're able to distribute, because it's now under the BigFix WW roots, down to the endpoints, and this is the data that will drive putting the machine back into place once we're done with it. Step 2, of course, was capturing the user state data, and again, this is built into BigFix out of the OSD deployment module. What we did, modify the default fixlet. Like I said, we did make it location specific. In large organizations, we realize the network share you're going to use is probably different. It's not always going to be the same. So based on IP address, we just changed the relevancy to pick a different network share. We did also change the MIG file in the user state XML to be company specific, and that was part of our MDT bundle kit. So let's take a look at how we did this. So first of all, we'll talk about user state. Remember we talked about that inventory data? Well, we showed you before that we had created that custom report, and that is now sitting in the BigFix server that can be pulled down. So we send this to all the Windows machines, and it's quite simply a way for us to switch the machine back, understand where his user state data is, put his old host name back in, and push the software out as we talked about. And I want to show you how simple this is. So first of all, the relevancy, simply the inventory text file does not exist inside of the Windows folder, and quite simply, we're going to pull down from that OSD directory we created on the BigFix server, that inventory report that gets generated once a day, and we pull out our serial number, and we're just looking through that file to match up and make sure our serial number is in there. If it is, we pull out just our information and save it to the newly imaged box. But we did this for a reason, that we push this inventory file out everywhere, and simply because in some of our testing we noticed that some machines had issues, especially in VMware with the serial number. Now again, we're not targeting VMware systems, but we decided to put a check and balances in. So forcing the network boot and even that CSG capture user state, I just wanted to point out that in our relevancy, we did add this line in here that the inventory file has to exist on a box. Because if the inventory is not collected on a machine, we don't want to start the process of our OSD deployment to Windows 10, basically wiping the machine out, because we won't know how to put it back into place and what its host name and stuff was. So we did add that relevancy in quite a few places here. And again, it's just added as a checks and balances for us. So that quite simple is it. Once we do that, we simply have our capture user state that runs based on its complexity of the system. It's going to capture the user state and store it on a network share that's location specific. Again, that's part of our Windows 10 migration. It's pretty much standard out of the box with some changes to the location state, and it will simply capture the user state, and that's in our workflow or in our baselines. So again, that was basically step 2, capturing the user state. Now that we have captured all the inventory and information about the machine, we're ready to wipe it. We're going to use the basic bigfix command to do this, and it is going to wipe the hard drive, enable the UEFI state, and then install Windows 10. We use some of the basic bigfix commands to do it, but we did have to modify the MDT bundle. That is in the customization PDF, however the steps are a little difficult. So we'll post the VB script that we got with IBM's help. However, after that, you're on your own to do some of your other vendors, because it was a lot of work on our part to actually make the other vendors work. So let's show you how it works. Take a look inside the bigfix console. And this should be useful to you, or you should have seen this before, the image library under the OS deployment and bare metal imaging. We have our images, and I have my Windows 10 image. And what we had to do is create a bare metal profile, and in this case I named it UEFI, just so that I could see it if I was looking on the binding menu. And I added some profile features to this. For example, let me edit this and show you. One of the important ones here is the host name rule. Notice that I call this PW10 dash and then the serial number of the box. If you recall earlier, we showed you that how endpoints that are newly imaged in this process get driven to the custom site. Well, their subscription is based off their host name, and they have to begin with PW10 dash. And then once they're in there, they'll start running the baseline. So that was part of it. You got to keep that in mind. The other thing to note is we did modify or take some of the bare metal operations. One of them being to deploy the profile to your bare metal targets. And again, if we look in here, we're going to notice that I have my Windows 10 selected, is what I'm trying to do, and my UEFI profile that I created. I want to make sure that this gets auto-launched when those machines actually show up. So how do you target machines? If you notice, it only shows me the machines that have pixie booted off our server or ones that I added myself. Well, we're able to do that. If you go under the RAD profiles, you could register computers to the bare metal server. And we did this, and it's based on MAC address. So we actually added machines in. Now, we could have automated this, but we did it in a controlled process. We may look at automating this or adding it as a right click later. And it's simply providing a MAC address list to the bare metal server we're dealing with. And again, since our system is separated by locations where our bare metal servers are, we could actually automate this where once machines reach the state where we know we got inventory, we're ready to go at the box, we could actually automate this task as part of our baseline. At the moment we did not, but we did send the MAC address down to those machines, and that helped us create this list here where you see like Cody and test OSD. This is the box that I'm going to hit next. So I actually ran the action on him already where I told it what profile to select, and it actually worked and ran on him. So this machine is now registered by MAC address right into our bare metal server. So you're going to see what happens when we actually deploy. The biggest difference here is I no longer have to deal with the binding menu, and I can make this automated. So let's watch. What you're going to notice as this server boots up and hits the Pixie server, it's actually not going to show the binding menu, which it normally would do. Now, we could have created a profile with a timeout value that auto-deployed, but we felt that was dangerous in any environment where we might wipe out a user machine we didn't mean to. So again, we don't do that. Normally we would see the binding menu show up, but since we deployed a profile to this MAC address, we're going to see that that task is going to get interjected here. And it takes a moment for the systems to talk to each other. But there you go. The binding, it sees that there's a pending task. The binding activity has been canceled. And what it will do is go right into the profile and bare metal image that we selected. and start deploying on this particular machine because it's based on its MAC address. Now this process takes a minute to actually lay down the image, so we're going to speed this up in this video and just skip past where the Windows 10 image actually gets laid down, and we'll continue the process from there. Now in the background we have our new endpoint. It's automatically added to BigFix, and it's going to start running the post configuration stuff. What we end up doing is turning on some screensavers to give indications or clues to the end user about the process of what's going on. We can watch that here. Update the background image. Just kidding about putting Mac OS here, but you got to have some fun while you're working. We also change the screensavers at each process step.